Hello friends, welcome to another video of Zeta Axis, and this is the second video in the 3 video series of local winds. And in this particular video we are going to discuss about the local winds which are front related winds. This is the list of all the local winds which we see around the world, and as we have discussed in our previous video, the local winds are specific winds in a region which are created due to specific atmospheric characteristics prevailing over there. Here is the list of all the local winds, and in the previous video we discussed in detail all these winds. They were katabatic winds. In this particular video we will discuss about frontal winds, and we will discuss each of them one by one. And in the upcoming video we will discuss about the winds due to pressure gradient. Now let's first understand extratropical cyclones, because understanding the mechanism of extratropical cyclone will help us understand the frontal winds. Here is an extratropical cyclone. We can see this is the warm air, and here is warm front, and this is the cold air which is moving towards the cold front. Remember, this is the boundary between cold air mass and warm air mass, and similarly here is also warm air mass and cold air mass, but this air is trying to move forward. So we see that because the cold air is heavier, the warm air will rise at an angle and it will create clouds along this line. Similarly, the cold air which is heavier will move the warm air and it will rise up. You will see thunderous clouds across this front. This is the cold front, and these are generally called squall lines. Now as this process continues, we will see that this cold front will reach the warm front. Now using this basic understanding, we can understand the local winds created by the fronts. So the first is Sirocco. Sirocco is basically a frontal wind. It is also created by extratropical cyclones. Here we will see that the warm air which we saw in the previous video, it is brought from the African region, from the Sahara Desert. So this air is dusty and dry over here. But as this air moves over the Mediterranean, it will accumulate a lot of moisture. So it becomes humid when it reaches the southern Europe, and it gives rainfall over there. Moreover, it also carries the dust particles along with it towards the southern European region. This wind, as it flows across the southern Europe, it is experienced by the whole region of southern Europe, and that is why in different areas of southern Europe it is called by different names. Let's see the characteristics of Sirocco. Sirocco is basically a Mediterranean wind, and it can happen in any time of the year, but it peaks in spring season. It originates over Sahara and reaches southern European region. It accumulates moisture over Mediterranean Sea as it flows from Africa to Europe. Because it accumulates the moisture, it becomes humid. However, it originates from Sahara, so it is warm and dusty. And this air mass moves towards the southern Europe because of the low pressure cells moving eastward across the Mediterranean Sea, which we saw in the previous video, how the extratropical cyclone was moving from west towards the east across the southern Europe. Now let's discuss the effects of Sirocco. It is dusty and dry in the northern coast of Africa. So this Sirocco, it causes dry conditions in the northern region of Africa because it is a warm air which comes from Sahara Desert. It creates storms in the Mediterranean Sea, and then it brings warm wet weather in the southern Europe. So it is carrying a lot of moisture with it. When it reaches the southern Europe where there are a lot of mountains, it causes rainfall there. It also causes blood rain. This blood rain occurs because the Sirocco carries a lot of moisture along with a lot of dust, which is from Sahara Desert. So as it reaches Italy, it will cause red colored rainfall because it is mixed with red sand, and this is what is called blood rain. Here we can clearly see the effect of Sirocco winds. They carry a lot of dust from the Sahara Desert in North Africa towards the southern Europe. They also accumulate a lot of moisture from the Mediterranean Sea. So when it reaches over there, there is a mix of rainfall as well as the red sand from the Sahara Desert, hence causing blood rainfall. These are the different names of Sirocco across different regions of the Mediterranean Sea. They are called by different names in Africa as well as southern Europe. The next important frontal wind is Pampero, where the air moves from the southern region or polar region towards the Pampas. These winds blow in the Pampas of Argentina and Uruguay. And because of this extratropical cyclone, we see that the wind reaches over here. So the arrival or passing of this Pampero, it indicates that there is a cold front which has passed. Now we know that these are cold winds, therefore they will reduce the temperature and cause a chilling effect in the region. This is a summary of Pampero winds, where we see that it flows over the Pampas of Argentina, Uruguay and southern Brazil. The Pampero is observed during the southern hemisphere's summer months. Remember, the summer and winter are reversed in northern and southern hemisphere. So it is seen in October to January. Pampero is basically the severe line swell that occurs in front of the cold front. That is, we saw that a line of thunderstorm clouds across the cold front. It marks the event of passage of cold front. And because it is cold current coming from the polar region, it severely drops the temperature. Pampero is usually accompanied by very humid conditions, and it gives severe rainfall, hailstorms as well as thunderstorms. Now here are the 4 local winds which we see in the South American region. Here we can see Pampero, which is basically a cold wind. Now it occurs mainly because of low pressure in this region. So this air, it moves across the Andes mountains, which is located over here. When it crosses the Andes mountains, it loses most of its moisture. It becomes cold and dry. It reaches this region where it encounters warm air. And this interaction could lead to formation of thunderstorms or even tornadoes. Here is the summary. It is caused by low situated over Patagonia or Falkland Islands, and it comes from the South Pacific region, and it passes over Andes where it loses much of its moisture. Therefore, it is relatively dry but cold air mass. And when it clashes with the northerly warm and humid air situated across the Argentinian plains, it could cause thunderstorms or even tornadoes can occur. The next frontal winds are Brickfielder and Southerly buster, which are seen in the Australian region. Here we can see an extratropical cyclone, and there is this warm air which is coming from the central Australia, and here there is this cold air which is coming from the polar region, and these are the fronts. Remember, this thunderstorm will move in the eastern direction. Now slowly this thunderstorm will sweep across the southern Australia. Thus first it will bring warm air and then it will bring cold air. Now this warm air that you see over here is called Brickfielder. Here is the summary of it. Brickfielder is a strong, hot, dry and dusty wind in southern Australia. It is dusty because it comes from the mainland where there are deserts. The Brickfielder usually occurs in summer and develops in the desert region. It raises the temperature because it is warm air, and it is associated with the passage of frontal zone. So we have seen that how the warm front is moving, and behind it we find Brickfielder. It carries clouds of dust and brings sudden hot spells. It increases the temperature because it is warm air, it is coming from the temperate zone, and it develops in front of a cold front. So we saw that cold front was behind the warm air. Now next, this cold air which we see is called Southerly buster. So this was Brickfielder and this is Southerly buster. So Southerly buster generally follows the Brickfielder. And here is a summary of Southerly buster. It is a southwesterly wind originating from the polar air masses, and it is also associated with cold front. The passing of cold front causes violent thunderstorms. We see that when the cold front moves forward, there is a square line, that is, there are thunderstorms on the cold front which can cause heavy rainfall. So the Southerly buster is uneven brother of Brickfielder, and it generally follows the Brickfielder. Here is another frontal wind which is called nor'easter, and it is seen in the eastern USA. Here we can see that there is a tropical cyclone, and these airs are moving in this region. Here is an example of nor'easter, and it is called nor'easter because it is moving from the northeastern direction, and this is a tropical cyclone. This is the typical comma shape. So these winds here are called nor'easters, and which means winds from northeastern direction. Here is another example. We will see that these are formed along with the jet stream. And here is a summary of nor'easter winds. It is a powerful coastal storm with strong winds, northeast winds. They typically form between Georgia and New Jersey, and they are most frequent through September and April. It is a large-scale extratropical cyclone that we saw. It tends to develop from September to April. We have already seen that because the difference in temperature between the cold polar air and the warm air that is coming from the southern direction. So here we have tried to explain all the local winds caused by frontal phenomena. I hope you liked our video, and if you have liked it, then do share with your friends and subscribe to the channel. If you like what you are doing, then you can use the Paytm ID to support us. Thanks for watching the video.